What is up, my main mathematicians? Welcome to section 2.1a, represent relations and functions. What is a relation? Everything you see here is a relation. These are all relations. We've got input paired to output, input paired to output, input in red paired to output in blue. These 5, 1, 3, these are the input that are paired to the output 10, 20, 22. I know the punctuation here is a little tricky, but that's what it's supposed to represent. What's the domain? Well, you just collect all of the relations input that produces an output. So if I make a collection here of the input, that's the domain. You can see here the domain is the collection of all the input. The range is the same thing, just the collection of the relations output that is produced by an input. So you collect all the output, that's the range. Now, what is a function? A function is a special kind of relation. So all of these are relations, but only some of them are going to be functions. A function is a special relation that pairs each input with exactly one output. If it's not a function, then it's a relation that has at least one input with two output or more. Now, to illustrate this concept of functions and input and output being paired, I have a guest here, a guest speaker. Why don't you all welcome Mrs. Bergman. She's here to help perform a couple of illustrations. Say hi to the kids.
Hi, everybody.
All right. So to start off, the first function is actually going to be a song. It's called "Let Me Clear My Throat," and it was put out nationwide around 1996 by a guy named DJ Kool. Now, DJ Kool was a master of working the crowd, live performances. He would get people going, and he would tell them how to respond. So it kind of goes like this. Now, if y'all want to party like we do, if y'all want to party like us, let me hear you say ah 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 ah.
Ah, 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 ah.
Now, when I say you say ah
Ah, ah.
When I say hey, you say ha, hey,
Ha.
hey,
Ha.
Now, if you think about it, up until this point, actually every input that DJ Kool had exactly one output. As you can see by this mapping thing, and the song worked really well when the audience knew exactly what to do, and he told them exactly what to do, and they had one thing to do, and they all shouted it in unison, and he just worked the club that way. It was great. And then he would say, now when I say freeze, y'all freeze one time. When I say freeze, y'all stop on a dime. When I say freeze, you're gonna freeze one time. Freeze! And that would be kind of like your opportunity to like throw up peace signs or just chill or whatever you want to do. You're gonna freeze and you're gonna strike a pose. And at that point, actually, because people had so many different options, it became not a function. So if this one input had multiple outputs, all of a sudden, you actually disqualifies it from being a function, because when he says freeze, then all of a sudden there were lots of things happening, lots of different things. One input had more than one output. So we're going to do a few more of these illustrations, and we'll try and think about whether or not they're functions or not. Everything here, every mapping is every pairing of input to output is called a relation, but some relations are special and they're called functions. So let's take a look at this. Here, let's take a look at this one right here. So I'm going to say an input, and my wife, Mrs. Bergman, is going to say an output, like this. Ready? 8.
B.
5.
A.
1.
C.
And because it's really clear, and because every one input has one output, then you can say that it is a function. This definitely a relation, but because it has every input has one output, then you can say it's a special kind of relation known as a function. Let's do this one over here. The punctuation might be kind of confusing, but really, basically, this is the input, this is the output, this is the input, this is the output, input, output. So the domain, the collection of all the inputs are right here, and the collection of all the outputs are right here. I'm going to say the input, and my wife is going to say the output. Ready? 5.
10.
3.
22.
1.
20.
I think it's a function because every input has exactly one output. Let's take a look at this one here. Punctuation, there's just so many parentheses and all that, but don't let that trip you up. It's just input, output, input, output, input, output. All right, so I'm going to say the input, and she'll say the output. Ready? 3,
3.
2.
4.
Yeah, DJ Cool would not approve because his audience wouldn't know what to do. That some of them would say 4 and some of them would say -5. This is definitely not a function. Why? Because you have an input here that has more than one output, not a function. All right, let's go to this one here. Input, output, input, output, input, output. Let's take a look what the mapping looks like. It looks like this. All right, I'll say the input, and my wife is going to say the output. Ready? 1,
3.
0,
2.
-1.
3.
This would definitely pass the DJ Cool test. It's not very cool. It wouldn't work the crowd, but at least the crowd would know what to say. Every input has exactly one output. So, ding, yes, it is a function. Let's see. What about this one? I'm looking at 4 going to 12 and 4 going to 15. 5 going to 18, 5 going to 21, 6 going to 24. Ready? Here we go with the inputs. 6.
24.
5.
I don't know.
Right, because there's 2 options. All right, all of a sudden, right away, you know it is not a function. Let's see if we can, maybe we need to zoom in a little bit on this one. All right, you ready? 10.
2.
5.
8.
4.
8.
3.
3.
7.
4.
What do you think?
Yes.
Yeah, she's a quick learner, and she took calculus, so she's good at math too. All right.
Long time ago.
Yeah. Thanks. Say bye to the kids.
Bye.
Now, because the definition of a function has so much to do with how many output each input has, like the definition actually has a number in it, and it's exactly 1. It's really helpful to actually just count how many output each input has, like this. I'll start over here. Let me clear my throat. All right, so how many output does the input have? It has 1. What about It also has 1. How about hey? It only goes to one thing. So, as you remember, at this point, looking into the relation, let me clear my throat, each input has exactly one output, and so therefore at this point it's a function. But as soon as you say freeze, there's 2 picture, there's way more possibilities here. So because of that last line, 2 or more, there's at this point it's no longer a function. It's just a simple relation. Let's count the output over here in the next one. So how many output does 2 have? The number 2? It has 2. It goes to -5 and 4. And what about 1? 3. 3 has 1. So here you can see that because of this 2, it's not a function. Next one. -1 has 1 output. 1 has 1 output. 0 has 1 output. So therefore, since they're all 1s, yes, it is a function. What about over here? You can see the input 4 has 2 outputs. The input 5 has 2 outputs, therefore, and the input 6 has 1 output, therefore not a function. Zooming in a little bit, let's count the outputs here. This input, 1 output, 1 output, 1 output, 1 output, 1 output. That's a function. Why? Because it's a special relation that pairs each input with exactly 1 output. Each input here has 1 output, therefore it's a function. Let's take a look at these. These are really tricky. Students get confused on these all the time. So let's count the output. Here, this input has 3 output, so not a function. Here, this input has 1 output, 1 output, 1 output. Therefore, yes, a function. They kind of look similar. There's like this. We have this like 3-to-1 arrow situation going on. There's a 3-to-1 arrow situation going on here. But this is, and that's why they're confused all the time. But you have to look at the inputs and count the number of outputs each has. This has one, this has one, this has one. Therefore, yes, it is a function. All right, let's take a look and see what's going on. Big picture. Oh, so over here, this is a new way of showing relation. Basically, each point that you see on this graph, all the x value is in the domain and the output is in the range. So the x value pairs to the output, to the y value. So let's just take a look at this here. If I say 0 as an x value, that's where this y-axis is. It actually has two different y values. X is 0, y could be this number here. What is that? I think it's positive 3 and negative 3. So therefore, it is not a function because this input has two outputs. Turns out there's a shortcut for analyzing graphs. It's called the vertical line test. If every vertical line touches the graph at most once, that it's kind of like up here, exactly once, then it's a function. All right, so it's going to be really important to take a look and draw a vertical line that represents the x value of your choice and see how many y values there are. So here, when you draw this vertical line, you're choosing this x value, and you're seeing how many there are. There's exactly 1. Good, that's why it's a function. 1, it's exactly a function. How many times does this vertical line touch the graph? Once. That's why it's a function. Here, I'll let you figure it out. How many times does this vertical line touch the graph in order to make it a function? So let's take a look at some examples that are not functions. You draw this vertical line, you say, okay, and when x is equal to 5, that's the input, what's the output? Well, this vertical line shows you that there's a point here that's 2 and a point here that's negative 2. So this vertical line has two outputs. Therefore, it is two outputs, not a function. This vertical line, if the input is 2, the output here in this case shows you it's positive 4 or it could be negative 4. Therefore, not a function. Vertical line here, if I said negative 3, there's 3 different possibilities for outputs. Negative 3 goes to this number, and this number. This vertical line shows you that there are 3 outputs for that one input, not a function. Over here, the vertical line of positive 3 tells you when x is 3, y could be positive 2 or negative 2, not a function. Let's take a look over here. So we see on your packet, you see there's this parabola, and you could draw as many vertical lines as you want. And at every point, at every line, it touches exactly once. So this vertical line touches once. This vertical line touches once. This vertical line touches once. Therefore, yes, a function. What about over here? This vertical line touches 2 different points. These closed dots actually do count. If it were an open dot, it wouldn't count. I would change this 2 to a 1. Actually, I think I need to change this green 2 to be a blue 2. Yeah, because these, and maybe these, we need those blue also. All right, so in any case, because the blue 2 has been the blue 2, the blue 2s are like counting how many times it touches. So here, when I say x is equal to 3, then there's 2 different outputs, positive 2 and negative 2. Therefore, this vertical line is it's touching 2 different points, and I know that's too much to be considered a function. All right, y'all, that's it. If you want to do some additional research on relations and functions, go ahead and put up Spotify. Let Me Clear My Throat, 1996. It was a wild time. Take care, y'all. I'll see you in class. And maybe you can tell me what your favorite call and response song is. See ya.